Thank you very much, Professor Chivase, Vice Chancellor, Professor Benzo, the Dean, members of the University Management, students, members of the SRC, if present here, my colleagues from the National Nuclear Regulator, ladies and gentlemen, thank you for having me today. I need to make a disclaimer that I really did not expect the Vice Chancellor to be here today. It was an appointment that I had with Professor Benzo and Professor Chivase and the students. So, Vice Chancellor, thank you very much for honoring this with your presence. And coming to the Northwest University is always, Mafikeng campus in particular, is always that homecoming feeling. It's like one visiting home. Now, when you are at home, I come from a village, that other side of Rustenburg. When you're at home, you normally don't talk about what you do at work. You try to keep it so that people don't think you're bragging. So I feel a bit awkward to tell the people from home today what I do. And when we're at home also, Dr. Chivase, you'll know this, when you're in Venda, you don't get the honor of people reading such a long CV about you. So it also humbles you a little bit. So thank you for the very kind introduction. We decided as the National Nuclear Regulator to be here today as part of our series in public lectures across the country, in particular at universities, to inform the public, to talk to the public about particular aspects of nuclear power, nuclear energy, nuclear technologies, but in particular, we want to talk about what we do as a regulator. Now, the Northwest University is the second in a series of these lectures. We had one about 3.5 weeks ago at the University of Cape Town, and we talked about the same topic. We will also theme these topics to reflect a broader perspective of the nuclear field, but not forgetting our area of responsibility, which is regulation. So the next in a series of these lectures will take place in the Witwatersrand University on the 13th of November. And we'll talk about that later. So the first thing I want to tell you about is a little bit of history about the nuclear landscape in South Africa, in particular the history of this organization that I am so honored to be the head of, the National Nuclear Regulator. And then, like it or not, when you talk about regulation, you have to talk about legislation. So nuclear regulation is a science, I always tell people. It's purely science-based. But you make decisions based on science, and then you apply those decisions through legislation, through the law, to make them enforceable. So I will talk about the regulatory framework and legislation that governs nuclear. And then we'll talk about the nuclear industry role players in the country. You've heard already that our mother department, the Department of Energy, Minerals, nowadays it's called Mineral Regulations and Energy, is also here. So you will see the bigger picture and the landscape of who is involved in nuclear affairs of the country. Then we talk about the NNR itself at a glance and facilities that we regulate, the principles of an effective regulatory body. Then we talk about our efforts as the NNR to improve those principles, or to adhere to those principles of effectiveness. Then I look into the current major regulatory projects that will interest perhaps some of you students and professors, researchers, and indeed the members of the public, because it also affects them. And ultimately, nothing is always rosy, so we'll talk about challenges, and then we conclude. Now, this is a busy slide that shows you the history of nuclear in the country. Of importance here is the fact that as far back as 1948, now when the apartheid government became popular, 1948, that government set up what was called at that time the Atomic Energy Board through legislation. And then also very important, a few years down the line, the government at that time acceded to what is now popularly known as the International Atomic Energy Agency. They became a member, they signed that convention, and it is also a very good thing to note that we're actually the first African country to accede at that time, and to date we still remain a member of the Board of Governors of the IAEA. And most importantly is 1963. 1963, the government at that time decided that you cannot have nuclear technology without regulating it. So that is the time when they decided that in the Atomic Energy Board, a particular division must be set aside to look into regulating nuclear. The rest is history, but of relevance today is that in the year 2000, the act was promulgated called the National Nuclear Regulator Act, which brought into being the existence of the National Nuclear Regulator as we know it today. So, if you look into this again historically, South Africa is a global player in nuclear affairs. As I said, we are a member of the International Atomic Energy Agency, and consequently, therefore, we are a signatory to a number of conventions. A few to mention here are the Convention on Early Notification of a Nuclear Accident. We'll talk about that later. But nuclear is fun, and nuclear can be such a nasty thing should things go wrong. So when there is an accident, the country is obliged to inform its neighbors as early as possible, because a nuclear accident does not only affect the country where it happens, but it affects the neighbors and everybody, and we'll talk about that. Again, Dr. Shivase has said earlier that I am actually currently the president of the Joint Convention Review Meeting. That's one of the very important international conventions that our country subscribes to and has acceded to, which governs how we handle radioactive waste and spent fuel in the nuclear environment. We also have this convention. Okay, let's leave this one. This one, most importantly for today, I'm not going to go through all of them, is the Convention on Nuclear Safety. Now, that is the basis of the existence of a regulatory body such as the National Nuclear Regulator. And we'll talk about that in the next few slides. Here we go. We say that South Africa has got these international obligations that I've just mentioned. And one such obligation is acceding to the articles of the Convention on Nuclear Safety. And Article 8 specifically says if you sign that convention as a contracting party, you shall establish or designate a regulatory body entrusted with the implementation of the legislative and regulatory framework. Now, that is how we were founded as the National Nuclear Regulator. And then that article also delineates the responsibilities. The regulator shall do this, but those that are being regulated are so-called license holders. The contracting party, meaning in this case the country South Africa, shall ensure that the prime responsibility for safety of a nuclear installation rests with the holder of a relevant license, and shall take appropriate steps to ensure that each such license holder meets its responsibilities. Now, those are the two very fundamental articles of the convention that delineates the role of an operator from the roles of a regulator that we are. Additional to that is so-called the nuclear safety fundamentals. Now, those are very important set of fundamentals that governs the entire nuclear and radiation technology practices and how we should conduct ourselves when we handle such materials. Principle number 2 sets out the role of government, and that role of government is to have an effective legal and governmental framework for safety, including an independent regulatory body that must be established and sustained. That is now why the NNR exists. Having said that, then let's zoom back home. South Africa is a country that practices different nuclear technologies and therefore has got different role players in the sector. Central to that, you have the South African government, the state. I deliberately say state here because these entities are not really government-owned entities, but they belong to the state, except for the Department of Energy. Now you can say this is a government department, but everything else here is a state entity. And the political science lecturers will tell you what's the difference between the government and the state in a different lecture. So we have the NEXA, which is one of our very important installations that we regulate as the National Nuclear Regulator. This is in Pelindaba, close to Pretoria, a very huge complex where some of our students at this university are trained in the Center for Applied Radiation Science and Technology that I also studied at. It is a very, very unique complex of its nature in Africa. And sorry. And so it is under regulation, has to be regulated. Also, we have the Nuclear Fuels Corporation, which is what manufactures what is called yellow cake, which is then exported and be enriched to make nuclear fuel. Then we have ourselves as the, oh no, see, technology and age. So the regulator here, and once you finish with nuclear materials, you must dispose them. But nuclear material, you can't just throw them in a dump, in the garbage dump. You need to control them because they are radioactive. So ultimately, you have this institute that must look after what you have used in the nuclear fuel cycle. Then we have a big facility in Quebec, which is the Quebec Nuclear Power Plant closer to Cape Town, which we also regulate. It is one of our very big treasures as a country because in the whole of Africa, this is the only facility, this is the only nuclear power plant in the entire African continent. As much as NEXA itself, it is a flagship institution in the entire continent. And then, of course, ultimately we have our Department of Mineral Resources and Energy. That is the mother department to all these entities that I've spoken about, except for this one, which is now under the Department of Public Enterprises. So how do we govern this regulator? It's got a board of directors, and that are appointed by the Minister of Energy, and they have fiduciary duties to look after. So they are my bosses, so to speak. They employ, they recommend to the minister to employ, and this board members are divided into different committees: the Audit and Risk Committee, the Technical Committee, the Transformation and Development Committee. We are a small organization of 177 people, and the most important thing I always gloat about when I'm overseas, I say, in fact, when I'm here also, I just told this to, a few days ago, I told this to another gathering that I was at. I said, more than 80% of the people that work for the regulator in South Africa have got postgraduate degrees in science and engineering disciplines as well as other areas of management. So that is a very important attribute for this regulator. It is headquartered in Centurion, and we have an office in Cape Town. It is headed by the chief executive, which is myself, and you have the executives here, one responsible for nuclear power plants, one responsible for nuclear technology and naturally occurring radioactive materials, NORM, We have a department that was recently, division that was recently created for regulatory improvement and technical services. We have the Chief Financial Officer's office, who is here with me today. We have the executive for corporate support services. And then we have other supporting departments that reports to the CEO also, which are the strategy, governance, and organizational performance. Legal, of course, you can't do anything without lawyers nowadays. And of course, internal audit, that must keep everybody on check to ensure that they do and they spend the money according to how it was intended. The framework, as I said earlier, regulation, nuclear regulation is science-based, but you need the framework, the legislation, to actually make it enforceable. And this is how it is done. We have the Act and regulations that are at the top tier of the pyramid as you see it there. Then you have nuclear authorizations, which we can call licenses. Then we develop so-called regulatory guides and position papers, which is now zooming into really technical issues and technical requirements that needs to be satisfied by each license holder. And then we develop technical reports, review reports, and research reports that we use in the regulation of nuclear. The process, how do we then regulate? We, as a starting point, of course, develop regulatory documents. So what are the requirements for any installation, nuclear installation? Now, nuclear installation means a nuclear reactor, nuclear power plant, research reactor, a waste management facility, and so on. All those are the ones that we regulate, and we'll show them later. So we develop those regulatory documents, and then you apply as a practitioner in a nuclear area for a license. We authorize you. And in the authorization process, we then also do reviews and assessments of the safety of your installation. And once we grant you those authorizations, we continuously do these reviews and assessment, but also we must inspect you to ensure that you continue to uphold the requirements and the conditions of your license through inspections. And once you violate the rules, of course, we need to enforce the rules through certain means, including directives and shutdowns, as they are now popularly or unpopularly known. One of our regulatory activities also that is very important and entrusted to us by the National Nuclear Regulator Act is to provide for emergency, to ensure that each license holder provides for emergency planning, preparedness, and response. In other words, should something go wrong, is there adequate measures in place to ensure that people do not get harmed, the environment does not get contaminated, and property does not get contaminated? So we ensure that these authorization holders of ours ultimately have these plans in place, and we, from time to time, go visit these installations to conduct so-called emergency drills, emergency exercises, which is something of a very large scale. You have, for example, we conduct this at the Quebec Nuclear Power Plant in Cape Town, where we simulate an accident. We say, suppose there's a big accident and people have to be evacuated. Can we see if you can do it? And so we give them an exercise and they perform that, and we invite people to observe and see, indeed, ESCOM has the capability to evacuate our people, to make sure that the environment and the food that people consume is safe if an accident happens. So that is one of our very important responsibility. Also, nuclear security. It used to be that many years ago, regulators were concerned about nuclear safety. But until September 11th of 2001, when the terrorists decided to fly a plane into the New York City towers, and people started thinking, we need to think beyond just nuclear safety. We need to think about nuclear security, because there is a good chance that a very, very explorative terrorist can decide to fly their aircraft into a nuclear power plant, for example, in Quebec. Are we having any measures against that? That is now what we call nuclear security, and part of our responsibility as a regulator is to ensure that measures to ensure nuclear security are in place with every regulator, every license holder. So what facilities do we regulate? We regulate the Quebec nuclear power plant. You can see it's a beautiful area. You would think you are going for a vacation when you are there, very close to the sea, very beautiful and pristine environment. You have even a small, you can call it a natural park, because it's a conserved area. You have fauna and flora grown there. You also have wild animals. You can, walk across and meet a kudu or a warthog. You have all kinds of different small game that is being bred there as part of demonstrating that nuclear can coexist with also life. This was built in 1984, 1 unit, so it's a 2-unit pressurized water reactor, and built from the Framatome design, which is a French technology. 1 unit, that's a unit, that's another unit. So one of the units was completed in 1984, another one was completed in 1985. Now that tells you immediately that these are very old units. And when they are old, you expect there may be problems. And we'll talk about that in some slides ahead. Another area that we regulate facility is the Nexa complex that I talked about. This is the complex. You see, again, very pristine environment, very close to the Hartepiesport Dam. There is the Hartepiesport Dam, as you can see there. So when you are in the Hartepiesport Dam, you look towards the south, you see these towers, these tall towers, and then you know that you are in the Nexa facility. You are very close to the Nexa facility. It is a very high security facility, so-called a national key point, and it's located, as I said, in the west of Pretoria. We also regulate where you put the waste. I talked about that. So these are the waste drums. It's in the Northern Cape, in a huge desert area where these things are stored and monitored from time to time to ensure that they do not contaminate the environment and nobody has unauthorized access to it, because it's very toxic and radioactive material. So here, Nexa, this is the research reactor at Nexa. So the first research reactor in Africa, no, I may be wrong, maybe it's the second after Ghana. GP, am I correct? Is it first or second? But Ghana also has got a research reactor. This one of ours in this country has now turned about 54 years old. So you can imagine also, very, very old facility. But it does a very good job so far to make sure that we conduct research and development at Nexa. Not only that, also we produced very important medication, that's so-called radiopharmaceuticals, which are used for the treatment of cancer. Now, one day, Nexa will come here and give you a lecture on the uses of nuclear technology other than just for energy production, because that's very important for people to know that in nuclear technology, you can produce electricity, you can produce radiopharmaceuticals, you can irradiate food. That's why you have apples sitting on the shelf in Pick and Pay that do not immediately go bad because they are irradiated, and vegetables and so on. So there are many important uses of nuclear technology, and that's a topic for another day. We regulate that. We also regulate the mines, precisely because some mines, in particular gold mines, once you remove the gold, and Professor Chivas talked about this in his inaugural lecture 2 weeks ago, once you process and take out the gold, the rest of the stuff that remains is very radioactive because you have a lot of uranium there. So you can actually also harvest uranium if you want from the byproducts of gold. We need, therefore, to regulate that to ensure that our brothers that works in the mines are not exposed to radioactive and toxic stuff. We have about 145 of these licenses that we regulate. As you know, South Africa is a very, very well-endowed country with minerals. We also have uranium mines that we regulate in this country, not only gold mines, but uranium mines that we regulate. So, having given you the background, let's talk about the core principles of what constitutes an effective nuclear regulator, which we strive to be. The first one is that it must have its primary focus on safety. Now, when you run a nuclear installation, you don't run it for safety, right? Quebec is not run because people want safety. Quebec is run as a nuclear power plant to produce and sell electricity from nuclear. We have to make sure that there is safety focus. So our focus as a regulator is nothing else but safety. The second principle is that the regulator must be independent. I read for you the two principles from the Convention on Nuclear Safety and from the Safety Fundamentals of the IAEA, that one of the core principles has to be an independent regulator. So, as you can see here, it is one of the important attributes of an effective regulator. You also have to be competent as a regulator. Otherwise, if you don't know what you're doing, the guys that you regulate will outsmart you. So we have to keep an eye on the competencies and the qualifications and the skills and abilities of the people that work for the regulator. Ultimately, you have to be open and transparent, because for many years, nuclear has been a very secretive affair. And therefore, if you are not open and transparent as a regulator, you then find yourself entangled in a lot of uncertainty. You actually create uncertainties. You actually create a lot of rumor mongering around your operators because you're not open and transparent. And how are we doing that? And what do we mean by independence? It means you have to be independent in regulatory decision making. In other words, you must not be susceptible to unwarranted external influences. You should not be influenced by the operators, by the politicians, by the public itself, by interest groups. You have to stay out of that and concentrate on the principles of your regulation. Your decisions must be based on science. Science only. As I said, nuclear regulation is science-based. Everything else is just a tool to enable you to enforce the regulations. But the basis of all this is science. So if you use anything else other than science to base your regulatory decisions, then it's a flawed regulation. The expectations must be clear, and that the reasoning for your decision making must be clear and must be clearly underpinned in your verdicts that you give for your operators' applications. You must be consistent and predictable. Now, building a nuclear power station, for example, is a very expensive endeavor. If you are not predictable, you will allow your operator to start a project, spend millions, billions around it, and then ultimately say to them, sorry, we're not going to give you a license. Now, that's a big waste. So predictability in regulation becomes very key. As I said, transparency, auditability, and traceability. So if we make a decision, we must be able 5 years later to trace it back to the basis of such decision and therefore be able to audit it. Now, we can only do that through legislation. Legislation must ensure that there is non-interference in decision making. There are clear steps to enforce the regulatory decisions. And that government has the leverage to advise government on any matters related to nuclear safety, because they are the most competent authority to be able to do that. They must be able to get enough financial resources so that they remain independent. Therefore, you need to have predictable sources of funding. Now, what we constantly ask ourselves, and we always check ourselves against as the National Nuclear Regulator, is to say, are we independent? Now, that is not enough to say we are independent, but are we seen to be independent? In other words, independence must both be demonstrated and be seen by the people on the other side of the aisle that you are indeed independent. As I said, government must ensure that through its relevant ministries, the regulator have all the requisite competencies. The regulator does not rely on a few individuals as decision makers, because then you have a problem. You have clear procedures and criteria for appointments of decision-making positions and access to external expertise. We must disclose information. If the public says, we think Dr. Chivasa is conducting some illicit experiments on nuclear materials in the lab at the Northwest University Mahikeng campus, we need to investigate that and disclose the information to the public. Transparency becomes key. Stakeholders involved in relevant decision-making processes through public participation mechanisms is also key. We need to involve the stakeholders. Therefore, we have various mechanisms for public participation. We're obliged to be transparent, as I said, but we need to protect sensitive information, because we can't just be opening up information. For example, some of the information may be nuclear security related, as a consequence become state security related. Now, what efforts are we putting to make sure that we are effective? We conducted a lot of self-assessments exercises to make sure that before anyone from outside comes and assesses us, we measure ourselves against international best practice, and where there are gaps, we come up with corrective measures. We have recently conducted an integrated nuclear infrastructure review mission, which was conducted by the International Atomic Energy Agency, a very huge and prestigious event that my staff and myself participated in. This took place in December of 2016 in Irene, in Centurion. You can see a lot of familiar faces there. This is the staff of the regulator, and this is not all of them. It's just a few of them that participated, and it was indeed a very auspicious event where we were assessed by 29 experts from 19 different countries worldwide to look into our processes, to look into our skills, to look into our regulations, and ultimately the verdict was that the National Nuclear Regulator is indeed an effective regulator, and we are very proud of that. Now, also we attend a lot of technical meetings and workshops internationally to ensure that we keep abreast with very, very recent and contemporary information on nuclear safety and regulation. We are a member of a number of international forums. One of them is the Forum for Regulatory Bodies in Africa. Now, one of the things that I omitted in the CV that Dr. Chivasa said is that I have the honor to be the deputy chairman of this forum. Of course, wherever you see NNRCO, just read NNR, because I don't represent myself, I represent the organization and the country. And the Regulatory Cooperation Forum, proud to be the chairperson of this very important forum, which currently consists now of 12 countries that are considering nuclear power as an option in their countries. You have Bangladesh, you have Sudan, you have Nigeria, you have Ghana, you have Vietnam, you have Belarus, and the United States is a member, France, Finland, and so on. So it's a very big body that we participate in to make sure that the knowledge from South Africa, the experience from South Africa is also cultivated internationally to ensure that ultimately the international infrastructure for nuclear safety and security is adequate. We also are part of a multinational design evaluation program, so-called MDEP, which is also a very prestigious membership that, in fact, we ourselves and Argentina are actually the only two developing countries that are members of this important program. And of course, I sit on the International Advisory Group, as Dr. Chivasa has said, which I also believe is a very important body that is the one that advises basically internationally everybody which is governed by the IAEA Director General on Nuclear Safety Affairs. Now, we also have very important capacity in the regulator, where we have the laboratory, which is the one that we use for verification, for testing of samples to ensure that when you tell us as a licensee that you have these kinds of results from your surveillance, we can be able to check that against our own measurements. We have that in Arcadia, in Pretoria. We have one also in Cape Town in partnership with the NEMISA. And this laboratory has successfully participated in 4 proficiency testing scheme exercises. And we are also a member of the International Atomic Energy Agency through our regulator, Almira Group, and we participate in annual proficiency testing scheme for radioactivity measurements as part of assuring the quality of results. I'm not going to bore you with the details, but this is the equipment that we have. Professor Chivase can see this, can be familiar with this because that's what I've just seen in our laboratories here at the CAST. And I'm very happy to see that the Center for Applied Radiation and Science and Technology in our university is keeping up with contemporary instrumentation. So we have those gamma spectrometry, alpha spectrometry, and so on. So those are very important equipments, as you can see there, state of the art that we use for analysis. Then the next is an important area of bilateral cooperations. Now, you cannot do nuclear alone. Nuclear is a global business. So you have to form partnership around the world because you need to exchange information, you need to benchmark against each other, you need to be able to ask assistance where you need some. And you cannot just do it out of the blues. It has to be based on certain international agreements, and we call those bilateral cooperations. Now, proud to say that the regulator of South Africa, the NNR, has a number of such. Recently, we signed the ones that you see here with China, with Finland, with Poland, with the Russian Federation, and indeed, we have existing ones that we are going, in fact, next week in Vienna, we are going to be renewing. These 2 have expired. I'll be signing again with the Americans and the British on this bilateral cooperation. These are very important tools for us to ensure that we have friends in the business. Whenever we need assistance, whenever we need to compare notes, we have them available. International knowledge sharing and dissemination. It is important that we don't only receive information, but we share it internationally. And we came up with something that we call the NNR RIC, Regulatory Information Conference, a very important and prestigious conference that is internationally attended. In fact, recently we had the first one the first conception was in October 2016. And you can see familiar faces there, most of them NNR employees, international experts, local experts that participated in that conference at the CSIR in Pretoria. And most importantly, and I see some school students here, most importantly, when we have these conferences, we invite high school students to participate in exhibitions, and you can see how many schools participated on that particular one. Quite a number of schools, so that they can understand nuclear from first principles and be able to choose a career in nuclear. The recent one that we had was last year, 16 to 18 May, also very well attended, as you can see, internationally, international participation, both very popular locally, domestically, and in some African countries that also participated. This was held in 4 ways at the Indaba Hotel in Johannesburg last year. Next, I want to talk about the Regulatory Emergency Response Center, what we call the REC at the NNR. It's a very important center. When there is an emergency, we should be able to communicate. If an emergency happens, for example, at NEXA, a nuclear emergency, there is radiation leakage, we need to be able, as the regulator, to detect that and advise the powers that be, advise the president of the country, advise the minister on actions that needs to be taken to evacuate people, for example, if needs be. So we have this center. It was finally completed in March 2019, and it's fully operational now. We can sit here, watch the screens, and receive real-time data from the nuclear sites that where the accident is happening. For example, you can see here, when we are sitting at that center, we can just log on to the Quebec nuclear power plant, and we can tell you exactly what the temperature of the primary system is, what are the pressures, because we read what the operators can see there. So it's a real-time information feedback system that a data management system that we are conducting at the NNR REC. And also, we have these online radiation monitoring systems. So if there's any leakage of radiation in any area of the country, we have now 19 of these, I should not say of the country, I should say in the vicinity of any nuclear installation, we have 19 of these data monitoring, online radiation monitoring systems that actually pick up radiation, if there's any radiation levels, and then it reports back to our center in Centurion, and we can be able to say, in Bretts, Madibeng, there is there are high levels of radiation, and therefore we need to investigate what must have leaked from Nexa. So those are very important installations that we run. Lastly, I want to talk about the Center for Nuclear Safety and Security, which is our flagship center for research, development, and training. This was inaugurated in 2016. It is based at the University of Pretoria, and it is actually the center that has got multiple partners. The University of Pretoria is the hub, and we have a number of universities that are the spokes to this center. Proud to say that the university that I am at today, the university that I graduated from, the Northwest University, is a member of this center, a very important partner. We have postgraduate students that are working hand in hand with this center, and Professor Chivase and his team are also very important stakeholders in this center. It is resting on 3 pillars, as I said earlier: education and training. So we teach, we train, we do research, and then we provide consulting services, technical support services. Dr. Mkosi, one of the alumnus of this university, also is the director of this center and the first one that was appointed to start it. So ultimately, what is more of probably of interest to you would be to know what major regulatory projects are we working on. The nuclear power plant in Quebec is aging, as I said. So 1984, 1985. Certain components of either we have to shut it down at some point, or they have to replace certain components. Now, one of the major component replacement is the steam generator at the Quebec nuclear power plant. And I will show you that later. It is a very important and huge project, in fact, costing Eskom about 4.5 billion rands to execute all this. Now, we as the regulator must get involved to ensure that that project is carried out safely and securely in compliance with our regulatory requirements and standards. There is also, okay, now here is the steam generator I must show. The steam generator is the biggest component in the nuclear power plant. So you have the steam generator and the reactor pressure vessel. So this is the biggest component and the heaviest also. So as you can see here, this is not just a picture. It is a picture of the steam generator that is going to be installed at Quebec. Our inspectors, this is manufactured in China and Japan, so different pieces from different countries, from Sweden and so on. They are ultimately assembled in China. Our inspectors go and inspect this manufacturing process to ensure that it is manufactured according to the codes and standards and according to our requirements. Now, this is a schematic of a nuclear power plant. One day I will come and give a lecture of how it works. But basically, this is the reactor itself here. So this whole building is called the containment building because it has to contain radioactive materials. So in here, you have nuclear fuel and water that heats. The nuclear fission reaction is initiated using a particular source, neutron source, and that neutron source causes fission. Fission then generates heat. heat boils the water, and so one heats up the water, and the water then, the hot water, then goes to the pressurizer, highly pressurized. Now the pressurizer works to ensure that ultimately you don't get boiling. So it just heats, but it does not boil. It's kept at a particular temperature. And once that is done, it is transferred to this component, which is the steam generator. That must generate steam, and that hot steam then goes out and drive the turbines. The turbines would then drive the generator and produce electricity, and the electricity goes to your home and town and schools. And ultimately, that water is then cooled down by some so-called ultimate heat sink. So here you may have the sea, as we have in Quebec and Cape Town. So the sea will then bring in cold water to condense the steam. The steam goes back as water and reused again, and the cycle goes. So that is basically how a nuclear power plant works. And we are in charge of this process to make sure that this component is replaced as per our standards. Now, it's not just one of them. You have 6 of them. So because each unit has got 3, it's a three-loop plant, so you have 6 steam generators that must be replaced. And you can imagine why it costs about 4.5 billion rands to do this. Then they have to replace the reactor pressure vessel heads. Now, I also put a schematic here so that you can understand what the reactor pressure vessel head is. Now, the pressure vessel is this part of the nuclear power plant. This is the pressure vessel, this is the head. And these are the control rods. One day I will come and talk about that to the physics students. These are the control rods that control the nuclear chain reaction, the fission chain reaction in the plant. So these also have aged, and they need to be replaced. Now look at how big this thing is. This is now looking from the top. This is the one that is already being manufactured to be replaced in one of the units at Quebec. You turn it around, you can see how huge this is. So there's a lot of, as I said earlier, Professor Benso, a lot of material science is involved here. You need to ensure that there are no impurities. It must be a very, very clean process, because any impurities in the steel can cause a lot of problems with the steel microstructure, and ultimately you can have cracking. You don't want to have this component crack. In fact, there has been an incident in the United States at a nuclear power plant called Davis-Besse, where after many years of operation, people realized that somewhere here, there was a gaping hole that was just about to appear. Because in a nuclear power plant, there's a very important liquid that is used for control called the boric acid. Now, apparently there was a small crack that propagated over the years, and boric acid was leaking out of this crack. And ultimately, it was by grace that we did not have, because this whole system is under very high pressure. So if any of these things could have given up, you would have released all of the reactivity into the environment. It could have caused a catastrophic accident. So that is why after the Davis-Besse incident, all nuclear power plants in the world had to inspect their reactor pressure vessel heads, and Quebec is now also replacing theirs. There is nothing that has been detected so far, but because we have learned lessons from Davis-Besse, we need to take proactive action, and that is why we're doing it. Another big project is the spent fuel. Now, when you use fuel in a nuclear power plant, ultimately it runs out of potency, if I can put it that way. And you have to remove it and put it, it's very highly radioactive and very hot. So you have to put it in the pool to cool it for years. Now, this pool in Quebec is almost getting full. So they need to find a way to make space for, if they still want to continue operating. Now, they are asking for a 20-year extension of their license. That means they will be taking out more fuel, spent fuel from the pool, from the reactor into the pool. Now, we're saying as the regulator, you can have criticality accidents if you have congested pools, concentrated pools. Therefore, they need to relieve and make space for their spent fuel, and they must now transfer it to so-called dry storage. So they need to remove it from the pool, put it in the casks, and then take it out and store it on site in some interim storage. Now, these casks must be manufactured in such a way that they will keep this highly toxic and radioactive material intact for years. The work of the regulator is to ensure that this is manufactured up to the standards, and ultimately the process of removing the fuel and putting it here and storing it is sanctioned and licensed by the regulator. Okay, I've already talked about that. The last one, before you fall asleep, is the replacement of the refueling water storage tanks. Now, every time after 24 months or 18 months for Quebec, you have to remove the fuel from the reactor and look at what can still be used. So you shuffle it around. So you have some that can still have some reactivity in it, so-called burn-up, lowly burn-up fuel. The other one will be highly burnt up. So the highly burnt out ones you remove, you put in the pool that I showed you. The one that still has got potency, you put it back in the reactor, and then you replace the others that you removed by fresh fuel. That's the whole theory. But as you do that, you need to keep the system underwater. So this huge tank is called the refuel. So that process is called refueling the reactor. So the refueling water storage tanks at Quebec have corroded. Now, if they still want to operate it for another 20 years, they need to replace them. Because, as you can see, this is an old one that is being removed, and these are new ones that were manufactured and replaced. So that is a big problem again, Professor Ebenzo, material science and metallurgy. It all boils down to making sure that these are manufactured into very, very high standards of purity and very, very concise standards. Challenges: we have a problem in the country where you have the national regulatory framework being fragmented. So Professor Chibaza would know this, that some of the sources that he has here are regulated by the Department of Health. And some of the sources, the radioactive sources, are regulated by ourselves. Now, the international community says it is not good practice to have too many cooks spoil the pot, right? Spoils the rod, right? The broth. So you don't want many cooks. So you need to have to harmonize your regulatory framework, because then you're not singing from the same hymn book, and therefore that is one of the problems that needs to be resolved. We have embarked on the process of taking the responsibilities from the Department of Health into the NNR. It's going slow, but fortunately currently the ministers, both of health and of energy, have agreed to this arrangement, and therefore we hope it will happen soon. We also have a situation where you have degradation of safety culture and security culture at nuclear installations. That becomes a problem, because then it puts a lot of pressure on the regulator to put more oversight. Now, I said earlier, the principle is that the prime responsibility for safety rests with the operator. The regulator is just there to ensure that safety is adhered to. We have had situations, for example, at NEXA, the NTP facility has had very, very serious safety culture issues. You've read about it in the news. And we continue to have those problems. And we realize that they are only and mostly cultural issues. Now, what does that mean? If in a nuclear environment, you don't take safety as a prime and very important attribute, you would then tend to prioritize production other than before safety. And that's what we've seen, for example, at the NTP at NEXA, and we've complained very bitterly about it, because we think that culture is wrong. We cannot go about continuing with that kind of culture. Then the security culture. We've had a very scary situation in Quebec. So I'm giving these examples because I have to be transparent. Told you about the safety culture at NEXA. The security culture at Quebec, again, is also very problematic. Recently, we had a situation where we had an intruder. Now, imagine, Quebec is a national key point. It's got multiple fences before you get to the buildings. And all these fences have got alarm triggers. You can't go through one fence without being detected. But on that very fateful day, you had this guy who decided to jump over the fence. The security guys are watching the screens. They can see him. Well, they can see there is a movement. The alarm goes off. They decide, it's probably an animal. And then he goes to the second layer. He jumps the fence. He triggers the security fence again. Oh, no, it's probably a bird. You know? Because that place is, as I said, is a national park almost. So ultimately, this guy gets to the buildings. Now, we are lucky that that guy had no ill intentions other than just theft. So the guy got inside the security. He breached the security area, got into a building, remained there for 8 hours undetected. 8 hours. And then left in the... How was he detected? When he left the building the following day, he was now confused how to get out. So he decided to follow the crowds. Now when he went to the main entrance exit area, because he was not aware of, he does not have the badge to get out for access, he tried to get out on the entrance. And then the security said, hey, wait a minute, where's your badge? And then that's how they managed to arrest him. And guess what? This guy had changed into the caterer's uniform. You know, he got into the kitchen, the catering area, changed into the caterer's uniform, and stole just one of his phone. So we are lucky. He just took a landline, not cell phone, landline, put it in a bag, and tried to leave. We later learned, of course, that the guy was mentally disturbed. So thank God that this is not a terrorist who entered the whole perimeter to cause havoc, because we could have had a big incident. So those are the challenges and consent, the degradation in safety and security culture in our nuclear installations. And that means the regulator must then keep up and watch closely. We have so-called nuclear installation site license that ESCOM had applied for. And now we know ESCOM wants to build more nuclear power plants. So one of the licenses to build the plant is in a place called Tyobeka in the Eastern Cape. Now we invested a lot of effort in adjudicating this license application, and then suddenly ESCOM has got big financial challenges, and they need to pay for a service for that. So ultimately, it brings a lot of uncertainty. But now this presentation is a bit outdated and by a few hours. Because this afternoon when I arrived at the hotel, I got an email from Mr. Jabu Mabuza, the chairman of ESCOM, to say that they are continuing with this. So we should be rest assured that there is enough money for that. And that's good news for us. So it's going to happen. Environmental contamination from the legacy mines. Professor Chivasa is doing a lot of that work with his postgraduate students. You have people that have come into this country many years ago, mined the gold, left the remnants of what they mined there and never guarded it or rehabilitated the land. That poses a lot of challenges for human health and environmental contamination. And these mining areas now, mining sites, some of them have become almost ownerless, and therefore you can't put a blame on anyone. That creates problems for the regulator, and we need to ensure that ultimately people are protected from these mines. So it is one of the areas where we expend a lot of effort to ensure that we share the responsibilities with the Department of Mineral Resources, Department of Water Affairs, Department of Cooperative Governance, and so on. It's been a very difficult collaboration to pull, but and then we're involving the universities also, like the Northwest University is heavily involved in that area. Competency and skills for the future. That is a challenge. You need to keep students interested in pursuing the nuclear career. Now, when you have a situation that says nuclear is dying in the country, then you have a problem where engineers and scientists say, no, I can't study for a dying career. Then we struggle to get the sufficient skills, especially for the future. We may have good skills now, but if we cannot interest you to join, to study this area, then we're going to have these problems. We need to always plan for the future because, as I always say, the regulator is the guy that is in a nuclear environment. The regulator is the one that has the key to shut down the installation. You can decide that today I'm out of business as Nexa, for example. But you can leave, but the regulator must remain and ensure that until you bring the area, the land back to greenfield, we continue to regulate. Therefore, the regulator is always the last man standing, and we need to plan for the future and as far as skills are concerned. In conclusion, as I have demonstrated, South Africa has a long history in nuclear technology and nuclear power. And a capable, effective, efficient, and independent nuclear regulator, we think, is a necessary precondition for safe operation of such technologies, as I pointed out. For 20 years, the NNR Act has ensured that we have this safe and secure operation of major nuclear and radiation facilities in the country through stringent oversight. We offer exciting and stable career opportunities. Why am I saying stable again? Because you hold the key to close, you are the last man standing. So you don't expect the regulator to retrench anytime soon because there is longevity in the career of a nuclear regulator. So we want and are always looking for career, for students and scientists and engineers with a questioning attitude. When you're a regulator, you must be able to question anything and everything and not assume anything until you have proven that it is what you think it is, or what it is actually. Physics, chemistry, material science, computational analysis, radiation protection, and environmental science, civil, mechanical, engineering, and metallurgy, etc., are the major areas of our interest. So if you are studying around these areas, you are a candidate for our bursaries. We have a number of students at universities, postgraduate and undergraduate, studying around these areas. And also, of course, you are a candidate for our internship program and our research associate program that Dr. Mkosi is even currently recruiting for. Ongoing collaboration with university partners like the Northwest University, we believe is essential for a sustained pipeline of skills to the regulator. Thank you very much. And as I said, this is a series, one in a series of these lectures, and we'll have the next one on the 13th of November. And that one will be looking at international approaches to licensing new nuclear power plants, and it will be at the University of the Witwatersrand. Thank you very much.